Hello and welcome back to geometry. Today we are going to look at a 19.4 for Moise, which is going to be on cylinders and cones. So basically trying to find out how to solve for the volumes of each one and also the surface area of each one. So here I have below, basically what I have, what I'm looking at, which is cylinders and also cones. And like I said, I want to find the volumes of each one. So let's go ahead and start with that one right there. And for a volume of a cylinder, that just goes by the postulate that we've been using, which is basically if you want to find the volume of something that's three-dimensional, you have to find the area of the base and then multiply it by the height. So that was postulate number 21 from the previous sections. So in this case, you can see that the bottom of any kind of cylinder is always going to be a circular part. So then that means that the volume is going to be equal to the area, which is pi r squared, the area of the circle, and then multiplied by the height. So that is going to be multiplied by h then. So that right there is going to be our volume of a cylinder. Now, for volume of a cone, we are going to use Cavalari's principle, which basically says that anytime you have a three-dimensional prism or three-dimensional figure where you have the bottom as a base, just as you would normally as a cylinder, but at the very top is just a single point, which is a vertex, like in this case of a cone, then that means the volume is going to be equal to 1/3 of the volume of the cylinder. So basically, it's going to be the same formula as the cylinder, except it's just going to be 1/3 of it. So 1/3 multiplied by pi multiplied by r squared multiplied by h. So let me go ahead and put that in there. Let's see, multiplied by pi, r squared multiplied by h. Right, so anytime, as I said, if you have, like, say, a base on one part and then you have a vertex on the upper part, then you can always going to use a cone. And the cone, you don't actually have to, you don't have to be an upright cone. So this is a regular, traditional cone. If your cone is positioned so that it looks something like this over here, you can still find the volume of it using the same formula, because you technically still have the height, you technically still have the area of the base. Even though it's slanted, it's still technically okay. All right. Okay, so that right there will be the volumes of each one. Now let's go ahead and talk about the surface area of each one then. So for the surface area, starting with a cylinder, you can think of it as kind of like a cylinder is basically a can, and that consists of two parts. You have a circle, which is on the bottom part. You have another circle, which is on the bottom part. And then on top of that, you have the side, which was known as the lateral surface. Okay, so this right here, the lateral surface, let me go ahead and write it out. So lateral surface. And the lateral surface, the way we define it is that it's basically the surface area that is not going to be either one of the base. So in this case, we just don't count the circle. For the lateral surface, if you can imagine that you have a can and you cut it right down vertically like this. So if you cut it right down vertically, the result is that you are just really going to have a rectangle. And the rectangle looks like the following. So if I can find the surface area, if I can find the area of each one and then add them all up, that's going to be my total surface area. So my total surface area looks like it's going to be equal to the two circles added together, which will be equal to 2 pi r squared because of two circles, and then add it with the area of this rectangle. The area of rectangle looks like there's a h right here for the height, and this part right here, that is going to be the circumference of the circle, because remember, you cut it vertically in order to get that rectangle. So that will be 2 pi r. So then that means the total surface area is going to be adding 2 pi r h into it. But whereas if I want the lateral surface area, then that is just going to be the 2 pi r h. So make sure you distinguish which one is each. Okay. Usually if they say just surface area, then that means it's the total surface area. Okay. Whereas lateral surface area, they'll literally say lateral. Now, as for the cone, it's going to be the same idea, but this one's a little bit more complex. So first of all, yes, you do have the circle that's on the bottom. So that one's easy enough. But for the lateral surface area, you're gonna have to do a cut just like you did with the cylinder. But the cut is not going to be vertical in this case. It's going to be a slant. So then that way it is. So then you can actually cut it. So imagine if you have like say an ice cream cone and you cut it to a slant where it's parallel to the side. The result, if you cut it then, is going to be a semicircle that looks like the following. So it looks something like this right there. So it's kind of like a pizza wedge or whatever you want to call it. So once again, we have the area of the circle, which is not that bad. But for this guy right here, for the slant, that's going to be a different story though. Let's see. So first, let's start with the following then. Let's first start with the arc of that slant, which is going to be this right here. Okay, so this sector of the circle, that slant, that is equivalent to the circumference of the circle, just like we had earlier. So that is going to be equal to 2 pi r. Now, as for this piece right here, the radius of this sector, that is not the height. So be very careful. The height is a vertical distance, whereas this right here, that is going to be this guy over here. So we're going to go ahead and call that L then, which is another word for lateral edge. Okay, so L stands for lateral edge. Okay, so I'm going to go ahead and put that in there. The angle, we don't know what it is, so we're going to go ahead and call it angle theta. And depending on, how wide the cone is, that angle might be a little bit different. Because if your cone looks something like, pretty fat like this, then that means that the arc, that central angle is going to be a lot bigger. But whereas if your cone is like, say, really skinny like this, then that means that you might have a area sector that's going to be a little bit smaller then. Okay, so the objective over here, once again, is to find the area of that piece right there. So what we can do is we can actually relate the two variables over here. Normally, the way we solve for the piece of an arc on a sector of a circle is the following. We say that we take the circumference, which in this case is going to be 2. Let me go ahead and change the pen. The arc is supposed to be equal to 2 pi r. That's the arc right there. And that is supposed to be equal to the circumference, which is going to be 2 pi multiplied by L, and then that multiplied by theta divided by 2 pi. So this right here is the numerical value of the arc that's given. And the right-hand side, that's how we would normally solve for it according to the radius of the circle then. So we can probably clean this up a little bit just to see where that leads us because we want to minimize the number of variables that we have. So you'll notice that the 2 pi's will cancel each other out. And then we can go ahead and maybe do a little bit of multiplication then. So r 2 pi is going to be equal to L multiplied by theta. So that gives us kind of like a relationship between the three variables. Now, once we have that, we can think of, like, say, maybe another relationship. So then that way we can solve for it. The area, which is what I'm looking for, of that sector is going to be equal to pi r squared, which r is referring to the radius of that sector. So that's going to be L squared, and then multiplied by theta over 2 pi. Okay, theta over 2 pi. And now we're going to go ahead and make a substitution just like we did before. And in fact, I think in the previous example, it might actually be better if I just leave r over on the other side then, because you can see that that might actually come out to be a little bit cleaner. So let me go ahead and write that. So r and then divided by L is equal to theta divided by 2 pi. Okay, so that is going to be my direct substitution over here. So pi multiplied by L squared multiplied by r divided by L. And so the surface area of that cone is going to be equal to pi r multiplied by L, where r is supposed to be the base of the cone and L is supposed to be the lateral edge. Okay, so that's how you're supposed to find it too. So in conclusion, if I want the total surface area, then that is going to be equal to pi r squared, which is a circle, plus pi r L, which is then going to be I guess the lateral edge. And it should be kept in mind that over here, if you look at the cone, the relationship is that L squared is equal to R squared plus H squared according to the Pythagorean theorem. So you can technically simplify this a little bit, so then that way it's only two variables. But whereas if you just want the lateral surface area, then that is going to be equal to pi r times L then. All right, so now we have the formula for everything. Let's go ahead and just kind of underline it just to make it a little bit easier, or just color code it. So here, 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 and then also here. And then you have this one, and then you also have this one. Okay, let's now look at an example of a problem. Here it says the altitude of a right circular cone is supposed to be 30, and the base has a radius of 8. A cylindrical hole with a radius of 4 is drilled through the cone with its axes along the on the axis of the cone, leaving a solid. What is the volume of the solid? Okay, so let's go ahead and draw that out so you can see how that looks like first. So first you have a right cylindrical cone. So what that means is we'll draw a regular cone where it's going to be an isosceles triangle. So that's what we mean by right cylindrical. So that is going to be what it looks like. The height of it is supposed to be 30, so I'm going to go ahead and put that in there. And in addition to that, the radius is going to be equal to 8, so that I'm going to also put into there. So right off the bat, we can solve for the volume of this cone and also the surface area of the cone because of what's given. If you're thinking, okay, I'm missing the lateral edge, well, you can use the Pythagorean theorem to figure out what L is, and that'll probably do the trick then. But since they're not calling for that, then we can just go ahead and disregard it for the time being. Now, what they're saying next is that there's a hole that is being drilled through it, and that hole is going to be a cylindrical hole. So that it means that there's a cylinder that burrows through the whole thing. And that one has a radius of 4 through it then. So let's go ahead and see if we can kind of fit that in there. If you have a radius of 4, then let's go ahead and start in the middle. And by the way, it says they share the same axis, so that's why I know how to do this. So I'm going to go out by 4, and I'm going to go up, and then I'm going to go out this way by 4, and then I'm going to go up. So here is basically that drill then. So as a result, then what that means is what they want us to find. And remember, when you drill this hole, you're actually going to cover the upper part of it also as well. So in the end, what is happening is we're going to have to find the volume of the solid, which is located over here. So this is basically the volume of the solid that I want. And let me see if I can kind of draw it a little bit better. So there it is. So if you can kind of imagine it, it looks like this then on the side then. So kind of like a little party hat, or maybe like one of those little seats that little kids sit on. And right in the middle, there is going to be a big old hole that is going to be an empty space then. So it's like a little potty trainer thing, okay? All right, so let's get to it then. So I think what will happen is if I want to find the volume of the solid, I need to basically find the volume of the cone and then cut out the pieces in the middle that we are going to disregard. So I am going to start first by finding the total volume, and that is equal to 8 squared multiplied by pi multiplied by 1/3 multiplied by 30. So that's the volume of a cone. Now, the first piece that I'm going to subtract will be the volume of the cone that is above it. So I need to get rid of this piece right here, right? Because that piece doesn't actually exist. I need to find out what is the radius, and I also need to find out what is the height. Fortunately, they did give us the radius, which is equal to 4. And unfortunately, we don't know what the height is, but we can solve for it because if you look at the setup, there is a proportionality that we can use over here. So drawing it on the side so you can see how that works out. 30 is the entire length. And then we have 8 over here, that's the base. And we know that this guy is going to be 4. So that means the height over here, if I'm looking at a proportionality of 1/2, then that means that h should equal to 15 because 8 divided by 4 is equal to 30 divided by h. And then we cross multiply to solve for h, which is equal to 15. All right, so the cone right there, that is going to be equal to pi multiplied by 4 squared multiplied by 1/3 multiplied by 15. So that is going to give us the volume of that cone that is right above it, that's over here. But if you remember, there's also that space, which is the cylinder inside, that's missing. So I need to also subtract that as well. So let's go ahead and subtract that then. Okay, so let's see. We're going to go ahead and subtract the volume of the cylinder that is inside right here. That one's not too bad. It's going to be equal to pi multiplied by r squared, which is r is equal to 4. Okay. And then you're going to multiply that by the height. Now, the height of that, that right there is going to be equal to 15 as well, because the height on the top is 15. So therefore, the height has to be equal to 15 on the bottom, because the sum is equal to 30. So multiply by 15 over here then. So we clean up the math, and that'll give us the volume of what we need. So let's see, that is going to be equal to pi multiplied by 64 multiplied by 10 minus pi multiplied by 16 multiplied by 5 and then minus 16 multiplied by 15. So I don't have my calculator. We're just going to go ahead and factor some stuff out. If I factor out the 16 pi that they all have in common, then that means the first part, that is going to be equal to 4. So there's 40. And then minus 5, and then minus 15. So whatever that comes out to be, 16 pi multiplied by, looks like it's 20 in this case. So 320 pi cubic units. So that will be my answer. Okay. All right. Well, thank you so much for watching. I will see you guys next time then. Have a good one. Bye.